We are going to continue talking about exponents, and we're doing a problem string called Dividing Like Bases, Part 2. We will do it in our composition book, take pictures, and upload it here. So this is the title, Dividing Like Bases, Part 2. So with division, we will be talking about fractions. So let's start out with 2 over 2 to the third power. If we have something like that, then let's go ahead and expand it out, because remember with division, you can expand them out, and anything that's on numerator and denominator, it simplifies to equal 1. So let's write as 2 over 2 times 2 times 2.
Oh.
So if we were to work this out or look at it, the 2's, what happens to the 2's? Yeah, that equals 1. So we are left with 2 times 2 on the bottom. And then what's left on the top? Yeah, 1. So this actually will equal 1 over 2 squared, or 1 over 4. Let's look at the next one. 3 squared over 3 cubed. What should we do?
You should simplify.
How?
You need to do 3 times 3, and then on top, and then 3 times 3 times 3 on the bottom.
Okay, good. Okay, so what can we do with that now? If it's on top and bottom, it actually simplifies to equal 1. So that's 1 times 1 times, and then 3 on the bottom. Do what? Oh, okay, yeah, don't add them together, because this is a multiply sign. So it'd be 1 over 3. Before we did all this exponents, we probably could have just done, let's go ahead and just multiply it out. So 3 times 3 would be 9 over 3 times 3 is 9 times 3 more is 27. And then we would reduce that. So 9 over 27 can be reduced by 9 by dividing top and bottom by 9, which gives us 1/3 also. So 2 different ways of looking at it. Which one would be easier? You like the bottom, simplifying after? What if they're really big numbers, though?
Well, then you should do the first one.
Yeah, then you know your multiples. Yeah, multiplication facts. All right. Remember when we did this one? When dividing like bases, you will subtract the exponents. So let's do it that way now. This was a couple days ago. So if I have 3 squared over 3 cubed, then I would rewrite it as the 3 and then 2 minus 3. Which is 2 minus 3, or 2 plus a negative 3, if we want to do it that way, be negative 1. Have we talked about negative exponents at all?
No.
We know that this is going to equal this. So what do you think that negative exponent does to the base?
It makes it a big fraction.
makes it as a fraction and puts it on, if it's up top, it's going to put it on the bottom. 1 over 3 to the first power, which is just 3. So that's to deal with negative exponents. Because the one that has the most 3's is on the bottom because it has 3 3's compared to 2 3's. And so wherever the bigger exponent is where that base will be. Let's do 5 to the 5th over 5 to the 3rd. Using, not expansion, using the subtraction rule. Dividing like bases, you subtract. So how do we get the solution to that?
5 minus 3 should be 5 to the second power.
Mm-hmm. Which in turn equals 25. I don't know my facts for 5 to the 5th power. I know 5 squared is 25. 5 to the 3rd power. Do y'all remember what that one was? We did it. 125. What is 5 to the 4th? 625. So 5 to the 5th would be something I'd have to do with the calculator. Remember, we're not using the calculator. So that's why this makes it easier. Looking at your exponents, subtracting them, and then you've already had you get your simplified answer that way. What if I switch these around and do 5 to the 3rd over 5 to the 5th?
3,125.
Comes out to what?
3,125.
Did you do it in your head?
Yes, I did.
And then you would have to divide it by the 125, right? And simplify it that way? That doesn't sound very fun to me. No.
I need to check this.
That's why I'd say let's use this rule. Because y'all are going to end up taking SAT, ACT, and if they have problems like this, there are non-calculator sections. So that's why you need to know how to do this without the calculator.
Take number sense one time, you'll know how to do it all.
True. Number sense is great for teaching you how to do things in your head.
Can you give like a real life example of how we use this?
I'm really not prepared to do that right now. I don't know. I'd have to do some investigation.
What?
All right. So let's look. So if we have it reversed, this is just a brand new problem. We're just starting fresh. What would we have? 5 to the negative 2. Which, what would that equal then?
Oh, 1.
1 over 5 squared, because anytime you have a negative exponent, if it's on top, you put it on bottom. If it was on bottom, you put it on top. And so that just equals the 1 over 25. So these are reciprocals. Do y'all remember that word?
Yes.
What do you mean if it's like on the?
So let's say, just as an example, we have 1 over 6 to the negative 2. We don't like negative exponents, so we would take this to the top and be 6 over 2, which equals 36. So your negative exponent could be on bottom, and you'd bring it up top. If it's on top, you take it down to the bottom. All right, let's do 5 squared times 2 squared over 10 to the 3rd power. Ooh,
Why are these problems difficult?
I don't know. All right, I don't see anything that has a like base, so I really can't do anything. But what do we know about 10? It's divisible by 5 and 2. Its factors are 5 and 2.
Easiest.
So what I could actually do is do 5. I'm going to do 5 times 5 times 2 times 2. I'm going to expand it out over. How could I write 10 to the 3rd but as 5s and 2s? 5 times 2 times 5 times 2 times 5 times 2, right? Because there's 3 of them. That's a 10, that's a 10, that's a 10. All right, let's rewrite it with exponents now.
Wait, I'm not done writing the question.
Okay. We could simplify by looking at a numerator and denominator that has the same, or we could go ahead and just look at put it back as exponents. So this would be 5 squared times 2 squared. So I really didn't need to do that. And then what would this be?
30.
5 cubed times 2 cubed. So now we can simplify because we have like bases. So we could simplify this by doing 5, 2 minus 3 times 2, 2 minus 3. And what would that be? 5 to the negative 1 times 2 to the negative 1. What do those negative exponents do?
Make them a fraction.
Yeah, so on top we don't have anything, so it'd be 1 over.
5 to the first.
Yeah, 5 to the first, 2 to the first, which what does that end up equaling? 10. So 1 over 10. All that work just for 1 over 10. Do you think there's an easier way?
Yeah, well, hopefully.
What if I instead decide to change the 5 and the 2's into a 10? Would that be easier? I think it would. All right, let's look at it that way. So let's change this. Instead of 5 squared and 2 squared, it would be, how many 5's do I have? Or let's see, how many 10's would I actually have? 2. So this would be 10 squared over 10 cubed. Whoa. I think that might be easier. So what would we write there? How would we simplify that?
10 to the negative 1.
10 to the negative 1, which equals 1 over 10. What do y'all think? Which one's easier?
That one.
Yeah, that one's easier.
Oh my.
Why'd you make us do all that work?
What?
Saucy?
Huh?
Why'd you make us do all that work?
I hadn't done this problem before, so this was, it just happened. I didn't know I was doing the harder way first.
That's nice.
I know, isn't it?
At least it gives us relief.
Yeah. All right, let's look at two-thirds to the 4th power times 2/3 to the 2nd power times 2/3 to the 5th power. This is a multiply. It's not a division, right?
Yeah. So you're gonna add the bases.
What do we do if they're like bases?
So you add the 4 and the 2 and the 5.
Find their
Which should give you
These are all positive, though.
12. 2/3 to the 12.
Okay, so this is just like saying a to the 4th, a to the 5th, or a squared, and a to the 5th. Because these are like bases. Don't let the fractions mess you up. If they're like bases, what do we do with the exponents? Add the exponents.
So it'd be 2 over 3 with an exponent of 11.
Yeah, because that's a, no. That's 6 plus 5. Yeah, 11. Yes. And you need to keep it in parentheses because if you have a fraction, then you need to have it to that same power. So it's a whole thing. All right, let's see. I think that's all. No, we'll do another one, and then we'll kind of write the rule. If I have 6 m to the 3rd power over 15 m, let's simplify that. Okay, we can separate these out and just be 6 over 15, simplify that, and then do m cubed over m and simplify that. They don't have to be right up next to each other. You can separate them out. So let's simplify this fraction. What can I simplify that by?
By 3.
3. So that would be 2 over 5. And then what about m3 times m? No, divided by, sorry. Huh?
Would it be 3? Don't you cancel out the end? Subtract the exponent?
We subtract the exponents. Remember, dividing like bases, we subtract the exponents. So this would be like m3 minus 1, which would be what? M to the second. Is it on top or on bottom? On top, yeah, because it's not a negative exponent. So 2m squared over 5. All right, so let's write something about negative exponents so we remember. If I have 4 to the negative 1, what is that going to equal? 1 over 4. So it puts the number on the denominator. If it's if there is a negative exponent, move the base to the denominator and change the sign to positive. And this is in the numerator. I'll just put it on top. If there's a negative exponent on top, which is our numerator, move the base to the denominator and change the sign to positive. So let's say I have 6z to the negative 2 over 5. Everything else will stay the same. The only thing that changes is that negative exponent because we want to get rid of it. So we keep the 6 over 5, but the z to the negative 2, we put it on the bottom. It'd be z to the positive 2. It's a z, not a 2. I mean, but the exponent's 2. So the only thing that will change is your term that has a negative exponent. Okay, so let's say that we have a 1 over b to the negative 2. So if there's a negative exponent in the denominator, you move it to the top and change it to positive. So this would be just b squared. So if there is a negative exponent on bottom denominator, move the base to the numerator or to the top and change the sign to positive. Okay, so another example, like 2 over A over 12 B to the -2 and C to the -1. So we will simplify the 2 over the 12. What does that equal? 1/6. So 1 over 6. A, we can't do anything there. What about B? Yeah, we need to put this up top, so it'll be B squared. And what about C? Put it up top. That means we really don't need this 1 anymore. We can just put A, B squared, C over 6. All right, so I want y'all to work on the back side of that homework from last night and complete this.